Hi there, I'm Sarthak and I'm here to explain one of most interesting and practical concept of physics. So let's start learning. Today I will be sharing with you the concept of mechanical properties of solid, out of which I will be dealing with a property which is known as elasticity. So before moving, I will like to explain the importance of this chapter, and after that we will deal with its technical part. So prior to this topic, we have studied ideal physics. I mean chapters like Newton laws of motion, where we studied ideal bodies. A string will be massless and inextensible, a pulley will be massless and frictionless. Another term we were using was rigid body. But practically no such body exists. I mean, for practical calculation, we cannot rely on those results. So this topic will bring us more closer to practical physics. Talking about its application, so it have a huge application in construction industry, like in construction of building and overbridges. Also engineering application, it have application in automobile sector, automobile engineering, also in manufacturing of medical equipments. So moving next, first of all I will explain you what we mean by elasticity. I will take an example. Suppose this is a rod, this is a cylindrical rod of unknown material. Now I will perform an experiment on this. I will fix it from one side. And on the other side I will apply a force. Now you have to imagine two situations. Situation 1, when I will apply a force, then this rod will get elongated. Its length will increase. Situation 1. Now situation 2, when applied external force I will remove external force, then body will return back to its original position. Body will return back to its previous position. Now if these two scenes, like when I applied force, it will get elongated, and when removed, body will return back to its position. When these two situation occurs, then the situation will known as elasticity. Talking about its definition, it's a property of body by virtue of which a body regain its original shape and size after removal of external force. Again repeating, a property of body by virtue of which a body regain its original shape and size after removal of applied external force. This is known as elasticity. Now again, for the same experiment, suppose for situation 1, I will apply force and its length will increase. But when I will remove force and it will not return back, I remove the force but it doesn't recover its original shape, then this case will be known as plasticity. Repeating again, if I will apply force, body will regain its shape, then it will be known as elasticity, and it will not regain its shape, then this will known as plasticity. Now talking about ideal cases, if body will regain its 100% shape, like applied force, it will get elongated and it will recover its original shape, then it will be known as perfectly elastic, 100% elastic or perfectly elastic. And again, if body will not recover its shape, 0% recovery, then it will known as plastic or plasticity, ideal plastic. So these two are extreme condition, ideal plastic and ideal elastic. 0% recovery means ideal plastic and 100% recovery means ideal elastic. A body which will show elastic nature will be elastic body, and which will show plastic nature will be plastic body. Talking about practical results, in universe no such body exists which is 100% elastic or 100% plastic. One fact we have that a material which is known as quartz fiber, which is 99.6% elastic in nature but not 100%. So we saw that what mean by elasticity and what is plasticity. So moving next, to understand this concept, we have two technical terms in physics. We will deal with this. The first term will be stress. And the second term will be strain. The first will be stress and second will be strain. Now we will understand what means by these two terms. Stress. Talking about the experiment, when I was applying the force, then due to my applied force, atoms on intermolecular level, atoms of this material were getting disturbed. I was applying action, then material was the atoms were applying reaction. I was applying force and there was a restoring force. I mean, when I applied force, particle get disturbed and it was under stress. The body was under stress, and this is known as stress. For calculation, we take when I have applied force, then there is a restoring force. Then the ratio of restoring force to its cross-sectional area. By cross-sectional area, I mean the part from where I am applying force. Here, this one is cross-sectional area. Here, this one is cross-sectional area. So, stress is defined as a ratio of restoring force to cross-sectional area. Talking about its unit, so force have a unit of Newton and area have a unit of meter square. So, unit will be Newton per meter square, which will be same as that of pressure. So, next term, which is strain. Same experiment, like when I was applying force, then body was getting elongated. I applied force, its length got increased. So suppose there is delta L change in length. There is delta L change in length. So this change in length will indicate us that body is under strain. And strain will be defined as change in length to its original length. Change in length to its original length, and it will be defined as strain. Talking about its unit, it is unitless and dimensionless, because in numerator we have change in length and denominator we have length into length, which got cancelled, and we have a result of unitless quantity. So we saw what is stress and what is strain. Now we will see what type of stress and strain we can observe. So here we have some, like stress. There are three type of stress we can see. One, longitudinal, second one volumetric, and third one shear or tangential stress. Talking about longitudinal, it gives us a sense of length. When a force is applied along length, then its length is increased, length is getting changed. So this one will be known as, if stress is along the length, then this one will be known as longitudinal stress. It may be tensile or compressive. The second one is volumetric. Suppose there is a 3D block, and I applied a force. I applied force from all the side, and the body will under stress. Then this stress will be known as volumetric stress. This will be equals to applied force to the surface area. Now the third one is shear or tangential. For that, imagine the same situation. Like this is a block and I am fixing it from the bottom. And from the top I will apply a force. But this force will along the tangent from the edge. And after that I will see that when I apply force, then body will get tilted. Now this is known as tangential stress. Tangential stress means this will be defined as the ratio of tangential force, which is along the tangent, to the surface area. Tangential stress will be tangential force to this surface area. Now similarly, for the strain we have three types. We also have three types of strain, which is longitudinal along the length, and volumetric along the volume, and shear which is along the shear, which is due to tangential force. Now we will, if I explain longitudinal, then this one will be change in length to its original length, and about volumetric, then this will be change in volume to its original volume. Now for shear we need to consider a situation. Suppose for shear, suppose this was our block fixed from the bottom, and when I applied force from its top edge, eventually body get distorted, and I saw that body got tilted and it was up to this thing. Body got tilted and it's this shape. Now this body is making an angle theta. This body is making an angle theta. Then tan of this theta will be known as shear stress or tangential strain. Shear strain or tangential strain. I mean that when I will apply external force on this body, the body will get tilted, and the angle which it will make from its original, from previous position, the tan of this angle will known as shear strain. So we saw that what is stress and what is strain and its types. Now based on a practical experiment, we got a curve which is known as stress strain curve.